Welcome to today's episode of Spelling Bee Ninja. Today's lesson dives into the intriguing world of logical reasoning, focusing specifically on advanced thinking skills. We'll explore key concepts, examine how to differentiate between formal and informal reasoning, and uncover common logical fallacies that can trip us up. Mastering logical reasoning is not only vital for academic success but also essential for navigating the complexities of everyday life. So, let's get started on this journey into the realm of logic. To kick things off, let's clarify what logical reasoning actually is. Logical reasoning is a systematic approach to thinking that enables us to derive valid conclusions based on premises. For older students, distinguishing between formal and informal reasoning becomes crucial. Formal logic operates with strict rules and structures, resembling mathematical principles. It typically uses symbols and defined truths. A classic example would be the syllogism, all humans are mortal. Socrates is human. Therefore, Socrates is mortal. This form of reasoning guarantees that if the premises are true, the conclusion must follow logically as well. On the other hand, informal reasoning deals with everyday arguments, which often hinge on probability and contextual evidence rather than absolute guarantees. For instance, consider this statement: most birds can fly. Penguins are birds. Therefore, penguins probably can fly. While this reasoning seems logical, it's actually misleading since we know penguins do not fly. Thus, the ability to identify when an argument requires formal certainty versus probabilistic reasoning is a hallmark of advanced logical thinking. Understanding which form of reasoning applies in various scenarios gives students a significant advantage in academic tests like the SAT and LSAT. Now, let's discuss conditional statements, which form the backbone of formal logic. A conditional statement, often referred to as an if-then statement, is written as if P, then Q. Here, P is the antecedent, and Q is the consequent. Importantly, this statement only asserts a relationship when P is true, and it makes no claims about what happens when P is false, leading to common logical missteps. For example, saying if it is raining, then the ground is wet does not allow us to conclude that if the ground is wet, it must be raining. The moisture could originate from other sources, such as sprinklers or spilled water. This mistake in reasoning is known as affirming the consequent. Similarly, concluding that if it is not raining, the ground is not wet, is another fallacy called denying the antecedent. The only sound conclusion derived from an if-then statement is its contrapositive: if not Q, then not P. If, for instance, if not wet, it follows that it is not raining. This understanding of contrapositives is critical in advanced logical reasoning, especially for assessments. Let's dive deeper into conditions. Both necessary and sufficient conditions are vital to analyzing arguments effectively. A sufficient condition guarantees that a result must occur if it is fulfilled. Using the example if P, then Q, whenever P happens, Q is certain to follow. In contrast, a necessary condition must always hold true for the result to happen. An example might illustrate this well: if you are a U.S. Senator, P, then you are at least 30 years old, Q. Here, being at least 30 years old is necessary to be a senator, meaning you can't be a senator without meeting this age requirement. However, being 30 does not mean you are a senator, which shows that being 30 is not sufficient. Arguments can easily confuse these conditions, so it is critical to understand them clearly. Another essential aspect of logical reasoning is the syllogism, which consists of two premises and a conclusion. The example we mentioned earlier illustrates a categorical syllogism, highlighting categories like humans and mortals. There are many types of syllogisms, but only a select few are valid. Validity can be tested with methods like Venn diagrams. For instance, all mammals are animals. All dogs are mammals. Therefore, all dogs are animals. This premise is valid. In contrast, consider a potential trap: some mammals are aquatic. Whales are mammals. Therefore, some whales are aquatic. Although valid, we need to carefully scrutinize premises for potential mishaps. Now let's examine the concept of inductive reasoning, which deviates from the certainty of deductive reasoning. Inductive reasoning involves drawing generalized conclusions from particular observations. For example, you may observe 100 swans, all white, and conclude, all swans are probably white. However, this can be misleading, as the existence of black swans showcases that our information could be incomplete or biased. Often, inductive reasoning appears in science, medicine, and everyday life, relying on evidence that can still predispose us to logical fallacies, such as hasty generalization. This occurs when conclusions are formed based on inadequate or unrepresentative samples. Furthermore, common biases such as confirmation bias and anecdotal fallacy can lead us astray. Confirmation bias happens when individuals seek information that supports their pre-existing beliefs, ignoring conflicting evidence. The anecdotal fallacy involves relying on personal stories over statistical evidence, making it a two-edged sword. Understanding these common pitfalls allows learners to robustly approach reasoning. Let's discuss logical fallacies like the red herring and the straw man, two deceptive tactics that can derail our arguments. A red herring diverts attention from the main topic. For instance, if someone proposes that we should invest in renewable energy to cut carbon emissions, a person responding with concerns over job losses in the coal industry is introducing a red herring, deflecting from the original point. Conversely, a straw man argument occurs when someone misrepresents an opponent's argument to make it easier to attack. For example, if one person advocates for increased education funding and another claims they want to bankrupt families, that's an exaggerated distortion designed for a rebuttal. Sharpening our awareness of these tactics enables us to engage in more fruitful discussions. Exploring truth tables becomes essential as we round out our discussion of logical operators. Truth tables help determine the truth values of compound statements based on their components. The basic logical operators include and, or, not, if then, and if and only if. Understanding these operators supports strong logical reasoning, especially in areas like computer science, where Boolean logic is foundational. For example, it is raining and it is cold only holds true when both conditions are satisfied. De Morgan's laws also play a significant role in our exploration of logical negations. These laws articulate how negation interacts with and or. For instance, the negation of P and Q is equivalent to not P or not Q. In simpler terms, if it's not the case that both conditions are true, at least one of them must be false. Lastly, we confront paradoxes, captivating yet perplexing statements that challenge our understanding of logic. The liar paradox, stating this statement is false, presents a self-referential conundrum. If true, it must be false, and if false, it must be true, creating a logical conflict. Such paradoxes aren't mere puzzles, they have broader implications in mathematics and computer science, revealing the intricate boundaries of reasoning and validity. As we conclude our in-depth discussion today, remember that mastering logical reasoning is not only about understanding definitions but also about applying these tools in real-world contexts. When analyzing an argument, identifying the main claim, checking if the evidence supports it, and guarding against logical fallacies are all vital steps. One of the most important questions you can ask yourself is, what evidence could change my mind? Developing this habit protects against confirmation bias and promotes critical thinking. Today, we have traversed the intricate landscape of logical reasoning, from formal logic definitions to practical applications in everyday debates. Remember, the essence of logical reasoning empowers us to think clearly, argue effectively, and engage meaningfully in the world around us. Today, we explored various facets of logical reasoning, including the distinction between formal and informal reasoning, conditional statements, necessary and sufficient conditions, and the structure of syllogisms. We also delved into inductive reasoning, logical fallacies like hasty generalization, red herrings, and straw man arguments. Furthermore, we learned about truth tables, logical operators, De Morgan's laws, and intriguing logical paradoxes. Each of these concepts contributes to your arsenal of thinking skills that are vital for effective reasoning. Thank you for joining us on this episode of Spelling Bee Ninja. We hope you found our exploration of logical reasoning engaging and enlightening. Don't forget to apply these principles to your daily interactions and academic challenges. Tune in next time for more thought-provoking lessons. Until then, keep questioning and analyzing the world around you.